The background of how this got started, it occurred at Dartmouth workshop in 1956 by a young professor called John McCarthy. And what he was doing is he was doing a summer research project, and he didn't call it artificial intelligence. He actually called it thinking machines. Okay, and what he did was that he organized a summer workshop in a duration of 6 to 8 weeks at Dartmouth College, and he brought in a lot of it was brain sessions, a brain session between mathematicians and scientists to come up with a way to improve machines thinking or learning. And he picked the name artificial intelligence. With the prediction of AI market, it's predicted that it would reach 3 trillion by 2024. Both industry and government fundings are so high to support this new technology. The system is very accuracy, and most people right now are using it in finance, pharmacy, energy, manufacturing, education, and transportation, and in public service in some places. So AI, we think about AI.
Move the bar. There's a bar. You are sharing your entire screen, so please move that bar to the end because it hides your
What bar? Oh, this bar. Okay. Okay.
Okay. Yeah. Please.
Okay. So we look at AI systems. We look at sensing systems. If you look at some of the cars we drive now, you have sensing systems that detect when you're too close and sends it back to the computer. Computer make a decision what to do. There's wearable technology, embedded system, specific application, and common sense. Sensing systems, wearable technology, are driving towards intelligent embedded systems. And you have to design an AI system specifically for a certain application. You just can't have a standalone system out there saying I'm going to use a program that can do the same function as, cutting grass versus, going to launching a spaceship. So the AI systems have to be a little different, modified to be able to use them. There's not a package design to fit all. So we have to be careful about using common sense when we actually use AI systems, because you see what happened when we tried to use systems that are designed by AI car accident. I think Luke made a reference to accidents with cars using AI systems, and we have to be practical when we try to use this system. Nope, I get it back. Ooh, okay, so who is using this system? If we look at the technology platform and AI application for significant impact, we look at Google, Facebook, Amazon, Apple, some of the big names out there. They're involved in AI application, and you see how they impact, what kind of impact they do, and what kind of programming they are. They're open source programming or whatever. You have different type of toolkits where people can communicate on certain platforms. So this is to give you a list of the major companies in AI at this point. And what programming language are used for AI? And you see right now, these are the ones that people typically use for programming. You can see the date on them. 1958 is the first one. And they're continuing to grow in Java 1995. And you can see the AI source and what influenced them. And then when I submit my document, my research, this will be included. Here's some more languages. that you can use, and Python is in there. I know we probably took Python. Essential research development for AI. We're going to talk about neural networks, deep deep learning, fuzzy logic, evolutionary computing, statistical learning, assembled learning, and meta algorithm, and logic-based artificial intelligence. Okay, so neural network basically is built in the area of connectism, with the main purpose of mimicking the way of the nervous system. Artificial network and variants have allowed significant progress of AI to pertain tasks related to perception. Okay, deep learning is a part of machine learning and is usually linked to deep neural networks that consist of multi-level learning or detailed representation of data through these different layers. And we'll look at some of these later on. And then evolutionary computing relies on the principle of natural selection or natural patterns of collective behavior. The two most relevant subfields included genetic algorithm and swarm intelligence. Statistical learning is aimed at AI exploring a more classical statistical perspective, based on modeling, adding the notion of prior knowledge to AI. Okay, assembled learning and meta algorithm is an area of AI armed to create models that combine several weak-based learners in order to increase accuracy while reducing its bias and variance. For instance, assembling can show a higher flexibility with respect to a single model approach on which some complex pattern can be modeled. Then the logic-based artificial intelligence is an area of AI commonly used to task knowledge, representation, and inference. It can represent predicted description, facts, and semantics of domains of means or formal logic. And since the development of hardware, these fields actually are ideal for we to start using exploring AI. It gives us the ability to actually improve on AI and make it more accuracy, have more accuracy to it. With the recent advances of such as parallelization, using the GPU, the cloud computing, and the multi-core processing, finally at the present of stage AI. And this deep deep neural networks have made tremendous progress in terms of accuracy. They can now recognize complex images and perform voice translation in real time. Multiprocessing, as you are aware of, this can speed up making a decision. So multiprocessing has actually been multi-core processing has actually helped with how things are produced, how things are looked at, and how fast it can respond to correct itself. So multi-processing and accuracy are a big part of this research that that we can compete with the development of AI to help us make decision quickly than the standard system where we have to use different networks. The old technology, been outdated, and as technology grows, the easier it is for AI to start learning and developing and become part of our everyday life. Okay. And here you see how AI has grown, machine languages, as you read from left to right, and where we are today if we go to the right. These so large scale learning using GPU 2012 ImageNet classification, AlphaGo, third AI stage hardware acceleration, real-time translation, DeepStack, deep belief networks. So we have progress, as you see, from back in 1956 when this actually started. A person had an idea of how we can make machines start thinking. And here's Bozeman machines, autoencoder, convolutional network, neural networks, recurrence network. If you read the bullet items on the side, you can see what each one represent. And it says Bozeman machine represent a type of neural network models by using stochastical units with specific distribution, for example, Gaussian. But if we look at the Bozeman machine, is a method for more hidden layers with directionless connection between the nodes, as shown in that picture. Okay, so basically, the advantage of this machine is the restricted machine, where the visible and hidden units are restricted to form a bi-party graph that allow implementation of more efficient training algorithms. The auto encoder, an encoder is a neural network designed to extract features directly from the data. This network has the same number of input and output nodes, and is a train used as a unsupervised approach to recreate the input vector. And it's composed of basically three components: an encoder, code, and decode. The encoder compresses the input and processes the code. The decoder then reconstructs the input only using this code. Convolutional network, neural network, CNN, that's what they call it, have been proposed to process efficiently imagery data. The name of these networks comes from the convolution operator that provide an easy way to perform complex operation use convolutional filter. So convolution put the input image through a set of convolutional filters, each of which activates certain features from the image. Okay. And recurrence neural network, RNN, is a neural network that contains hidden units capable of analyzing streams of data. Since RNN suffers from the vanishing gradient and exploring gradient problem, a variation called long short-term memory unit was proposed in 1970 to solve this problem. So RNN is a class of artificial neural networks where connections between nodes from a directed graph along a temporal sequence. This allows it to exhibit temporary dynamic behavior derived from feed-forward neural networks. RNN can use their internal state memory to process variable length sequence of inputs. And that's it. I hope the time, I try to cut it short to keep the time. But in the future, what they have predicted several things with the challenge with AI robots. We talked about vehicles, software pipeline, how we can control them. We also talk about dynamic state of estimation. These are what's coming next. And then laser mapping. The laser are the primary obstacle detection sensors on a vehicle. The viewer one of the 5 laser as it scan the terrain and it makes a decision. So these are future research projects they are working on. Working on a vision map